For our senior design project, we were tasked with creating a wearable ring that can monitor the pulse rate, oxygen saturation, temperature, motion, and position of the user. It's also meant for the user to wear every day and allow easy access to see their health vitals at any moment when necessary. So this is the temperature sensor. It's the Max 30208. It's connected directly with a ribbon cable that has the actual sensor at the very tip of it, and that is double-sided sticky taped onto the actual pulse oxygen sensor, which is inside the case right now. So you can place your finger on the temperature sensor just to collect your body temperature. Looking over at the evaluation kit software, you can see that it slowly reaches your normal temperature that you're looking for, which is typically around 37 Celsius or 98.5 Fahrenheit. So this collects live, and it takes a second to get up to your actual temperature, but it does eventually reach your normal body temperature that we're looking for. And you can also log this data through file logging, which is what will send our actual data to Power BI. So this is our pulse oxygen sensor. This is the Max 30102. It measures both pulse oxygen saturation and your heart rate, given from the red AC and DC values. So it's attached directly with a ribbon cable to our sensor itself. This is the pulse oxygen sensor, and this is the temperature sensor. So when you place it on your finger, you can look at the evaluation kit software, and you can do a time data collection, say for example 20 seconds. So we'll hit start monitor, and then you can see that the accelerometer values for the X, Y, and Z values, they change with movement of the actual piece itself. And then from these red AC and DC values, this is what collects and basically gets our heart rate and our pulse oxygen saturation. So we have two algorithms that come with this evaluation kit. We have a PBA algorithm. It shows your beats per minute, your oxygen saturation, and then we also have the SKA algorithm. So we decided this algorithm is the one that we'll be using more for the Power BI output display, as it seems to be more accurate. So this is our complete project as a whole. It's placed in our 3D printed case, and then you have our actual sensors down here on the inside of the finger. So we decided to put the case on the inside of the wristband due to the length of the ribbon cable. So this one's fairly short, and it wouldn't work to be on the top side of the wrist. And we also put the sensors on the inside of the base of the finger, as it reads your red AC and DC values a lot better than it would if it was placed on the top of the finger. So this is how it looks as a whole.
The data collected from the sensors are stored as CSV files, and they're uploaded through the file upload option on Power BI desktop. The first step is to clean the data using the data cleaning process, and we remove a lot of rows and columns that's not necessary, and also has a lot of null values and errors that we need to remove as well. Once we finish the data cleaning process, we do use the close and apply option, and then we click the publish option. Then we see the graphical representation for both the sensors. There's different options to change the type of graphs that we want. Here we've used the line graph. There's also option to have the average temperature and the oxygen saturation rate, as well as the heart rate sensor data to be displayed as well.
Overall, this device accurately measures all the necessary health vitals and transmits the data to the display application, which is through Power BI. It is also wearable and low profile. Our future work would include implementing an independent power supply and Bluetooth features for wireless data transmission. We'd also include a phone application for easy access to see your health vitals, and we'd also include an alert notifications if the health vitals are outside of normal range.